By default, K6 already collects a bunch of metrics that we can analyze after a test run. In this lecture, we will explore some of the most important metrics. Metrics show us different views which can help us understand the application performance in a test situation. The goal here is to identify any issues, pinpoint what causes them, and fix the issues before they impact real people. Probably the most important metric to begin with is HTTP request duration. This metric shows how long it took from when we have sent a request until we have received a response. But as you will notice, there are also other things here like average, mean, median, max, P90, and P95. So what are all these things? Now, average, mean, and max are kind of like easy to understand. But what is P90 and P95? P stands for percentile. Let me explain. For example, P90 means the 90th percentile. It means that 90% of the requests were equal or faster than a given latency. For example, P95 is even stricter than that. So in this case, what it tells us is that 90% of the requests were faster than 402 milliseconds. And 95% of the requests were faster than 404 milliseconds. There's also a 99th percentile, but it is not displayed in this report. But wait, how about, the rest of the users? Like, why only care about 90% or 95%? Why not care about 100%? Or, for example, why not look at the average number? Imagine you're waiting in line to buy ice cream. You want to know how long it will take before you get your treat. Now, just saying on average people wait this long doesn't tell the whole story. For example, let's say on average people wait 2 minutes. Let's say that in a day 500 people visited the ice cream shop. 80% of the people got their ice cream in 20 seconds, while 20% of them got their ice cream after more than 8 minutes. So you can see how just looking at the average can be misleading. Some people got their ice cream really fast, while some got their ice cream with some delay. None of them actually got their ice cream in 2 minutes, which is the average. So instead of just looking at the average, we need to look deeper. We need to know how many people waited a little and how many people waited a lot. This is where percentiles come in handy. They help us understand the different groups of wait times. But why use the 90th or 95th percentile? Why not the 100th percentile? The 100th percentile would usually mean the maximum value in the dataset, but we already have max in our metrics. So that wouldn't make much sense. To summarize, when checking performance, don't just rely on averages because averages don't really tell the entire story. Use percentile. It helps us get a better picture of what is actually going on. So, what is a good response time? What is a good latency? Well, it really depends. Nothing is set in stone. For the sake of argument, let's say we want the latency for all requests to be below 300 milliseconds. Can we guarantee this? Absolutely not. Even if we send 1 million requests and a single request is taking 1 millisecond more than those 300 milliseconds we have set for us, we have failed. But that's not really fair, right? This is why we typically work with service level objective SLO. For example, a very simple SLO can look something like this. Or we can say something about availability. So we say, okay, the application will be available 99.8% of the time. We can never guarantee 100%. There's never an SLO with 100%, right? There's 100%, reaching 100% is practically impossible. The same goes for example, with the response time, latency. So we can say something like 90% of the responses are between 0.5 seconds of receiving a request, right? So this is something that we can have in our agreement. And apart from this, we can add and say, okay, this is for 90%. 95% of the responses are between 0.9 seconds and 99% of responses are within 2.5 seconds. So this means like 90% of the responses, 90% of people, they get their ice cream really, really fast. And only a small group of people will really, it will take a bit until they really get this, right? In other words, we care what happens with most requests and don't really care about some isolated incidents which we cannot really control. Sometimes people confuse SLA with SLOs. In a nutshell, they are related, but not really the same. I won't dig too much into this, so I included some links to the resources folder. So when we take a look at the K6 metrics, we are also trying to understand the service quality and check if our SLO is being met or not. Now, of course, there are also things happening on the server side. So, of course, we may want to monitor CPU usage, disk usage, memory use, and so on. But as you can see, if you're looking at this report here, K6 does not say anything about CPU. It does not say anything about memory or anything else. It doesn't know anything. And you're probably wondering why is the case? Well, because it does not have this information, as K6 is not really connected to the server running the application. But altogether, this is a topic on its own. I just wanted to mention it. K6 is not connected to the server, doesn't know like the ins and outs, what is happening with that particular server running the application. So for that reason, it also cannot display that information, but that information is also important. So to recap, simply for now, focus on the HTTP request duration and look at the percentiles because they are much more important than what we see here as average.